Lesson 5-1, Solving Inequalities by Addition and Subtraction. Our essential question is, how do you graph an inequality? Our vocab word today is inequality symbols. Inequality, if you think about the prefix to that word inequality, what it means is it's not an equality, not an equality. So in math class, when something is not an equality, when it's not an equality, it means it's not equal. So the symbols to represent things not being equal could involve a not equal sign, less than or equal to, greater than, or greater than or equal to. The symbols that we're going to focus on in this chapter are primarily these four. We're not going to work so much with the not equal symbol. You may see it a little bit, but not very much. Our first question here says, how do you graph an inequality? And then our second question, how do you determine if you use an open or closed circle on your graph? And our third, how do you determine which direction the ray is going? So in order to answer these questions, the first thing that I want to point out is, so we're going to be solving linear inequalities. We're going to be solving them just like we solved linear equations, but the solutions are going to look different because the solution to an inequality isn't just one number, like x equals 3. It's an entire range. It's a ray. It's a ray that represents all of the solutions. So there's actually an infinite number of solutions to an inequality versus an equation, which most of the ones that we've solved have one equation or one solution. So by changing to inequalities, we've actually really opened the door to the number of solutions that we have. So our graph is going to involve graphing on a number line. So how do you graph an inequality? You're going to graph a ray on a number line. And we are going to make sure that the variable is on the left, and then we're going to use these hints. To answer the question about if you use an open or closed circle, an open circle happens when you do not have an equal underneath your less than or greater than symbol. That means that you're not including the number that the circle is being placed on. So it's an open circle. You have a closed circle when there's an equal line underneath your symbol. So here, the line underneath, and here, the line underneath. Close the circle, because that means that your solution could be the number that that dot has been placed on, that your endpoint is placed on. It's included in the solution set because it could be equal to that number. Now, the other question, how do you determine the direction the ray is going? If your variable is on the left, the less than symbols will go to the left because that's where the numbers get smaller, to the left on a number line. So both of these go to the left. And then greater than would go to the right because that's where the numbers get bigger. Greater than goes to the right. What I'd like you to notice is that the arrow matches the symbol. Like the arrow on your ray, the direction that the ray is pointing matches. This happens only when your variable is on the left. Only when your variable is on the left. So I kind of think about it as a shortcut. If you solve your equation, always making sure your variable's on the left, then the direction that the inequality symbol points is the same way your ray is going to point on your graph. Okay, let's start doing some graphing now. So my first one has a -2. X is greater than -2. So I'm going to do an open circle on -2. There's no line underneath my greater than. And the arrow, the greater than, goes to the right. So my graph is going to go to the right. I'm going to make sure that I color in this arrow on my ray and make my line thick enough. On your homework, make sure that I can tell if your circle is open or closed, and make sure that I can tell which way your graph is going. You don't have to have this many numbers on your number line. If you have 3 numbers on your number line, that would be good enough for me. Okay, the next one is a circle, an endpoint on 4, and this one is closed because of the equal line underneath, so greater than or equal to 4. And another way that you might want to draw your graph is like this on your homework. You might want to raise it up a little bit above, so put the dot on the 4, and then you can raise your ray up a little bit if you want to show that graph. The next one, less than 1, so open circle on 1, less than goes to the left, where the numbers get smaller, and then the bottom one, -3, closed circle because of the line underneath, so it could be equal to the -3, and again to the left, less than or equal to. So these are just basic number line graphs, basic inequalities. On the next slide, you'll see we're going to start solving. So just like solving a linear equation, I am going to separate the 2 sides. I'm going to draw a line to separate the 2 sides of my inequality, just to make sure that my action step I'm doing once on each side. To get the x by itself, I need to add 8. -10 plus 8 is -2. So I have -2 is less than x. Remember, before I graph it, I want my variable on the left-hand side instead. So you may notice that this symbol opens up at the x. So I'm just going to reverse my inequality. -2 is less than x means the same thing as x is greater than -2. So I'm just reversing that inequality to get the variable on the left. Now I can do an open circle, and it's going to the right. X is greater than -2. So on this ray, you see an infinite amount of numbers that are greater than -2. Not the -2, because it's greater than -2, but anything to the right. -1, 0, 1, 2, 3, and so on. It goes on forever. And even any of the numbers that are in between. So that's our solution. Next one, 7 is greater than or equal to x plus 11. Subtract the 11 on each side. So -4 is greater than or equal to x. Reverse it again, so x is less than or equal to -4. I want my variable on the left before I graph it. Now I'm going to do a solid circle, closed circle, because of the line underneath on my symbol, less than or equal to -4, so it could be -4 or anything less. My next example, I have a variable on each side. You can solve this in a couple of different ways. I'm going to solve it by subtracting the 3x on both sides. I know I want my variables on the left. I know that, but I'm not going to eliminate the 4x when it's the only thing on its side. So remember, when we solved equations like this, this is what we did. If there's one term by itself, we left it alone. So 1 is less than 4x minus 3x is 1x, which is the same as just x. Now reverse it. X is greater than 1. So open circle on 1, greater than goes to the right. Next one. I have a variable on each side again, so I'm going to subtract the 4x because the 5x was alone. 5x minus 4x is 1x, so x is greater than or equal to -2. The variable's on the side that I wanted, so closed circle on -2, greater than or equal to, so it goes to the right. This slide we've got a click and drag, just to try to get more familiar with some of the words that represent these symbols. So first of all, less than, or equal to, greater than or equal to, and greater than. So those are just naming your symbols. Now another one for less than could be fewer than, fewer than. For greater than, it could be more than. Now, these last ones are a little bit trickier. No less than. If something is not less than, so think about if I have no less than $10. So I do not have less than $10. That means that I might have, like the exact opposite of saying that I have less than $10 would be greater than or equal to $10. So I do not have less than 10. So the other options are to be equal to 10 or more than 10. Okay? So then no more than, if I do not have more than, no more than $10, that means that I've actually got 10 or less. Those are tricky. They're tricky. So if you think about them as opposites, like if more than is greater than, if it's not more than, you've got to find the exact opposite symbol. Kind of similar with the at least and at most. If I have at least $5, at the very least I've got 5. That means that I've got 5 or more. So at least would go here, greater than or equal to. So you see the word less and you see the word least on these two over here, and it draws you to the less than symbols, and it's not. It's not. You've got to think about it. Try to think about it. The words are pretty tricky here. And at most, if I have at the very most $5, that means that I don't have more than 5. At the very most I have 5, that means I've got 5 or less. So less than or equal to. So those words might take you a little while to get used to. All right. Now use an inequality to solve this problem. An inequality. So that means we have to have an inequality symbol. Sam has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sam wants a pair of jeans, how much can he spend? How much can he spend? Now, I know that you guys can look at the numbers and I'm pretty sure you can figure out, what you want to do with the math, but it says use an inequality. Use an inequality. So that means that we need numbers, we need letters, or a letter, like variable. So numbers, letters, and we need symbols. Numbers, letters, and symbols. So think about all that stuff. So we need to use the numbers. So we've got the 65, the 18, and the 14. We need a variable like X. That's what I mean by letter or letters. And we need a symbol, like one of these symbols in our inequality. So think about how we put this together. He's shopping, okay? He's shopping. He has $65 to spend. So to me, that means I'm going to put the 65 over here. Like that's what he's got, $65 to spend. Now, can he spend greater than or equal to 65? No, you can't spend more than you have. Can't spend greater than 65. Can he spend exactly 65? Sure. Could he spend less than 65? Sure. This is the best symbol to use because he could spend right up to the $65, okay? This less than symbol would be good if it said that he had to have change, like he had to have some money left over, like he can't spend everything he's got, but this doesn't say it. It says he has $65 to spend at the mall. So he can spend 65 or less, so less than or equal to 65. Now on this other side, I want all the stuff that he's going to buy. So he bought the t-shirt, and he bought the belt, and he wants to buy some jeans. So these would have to add up to less than or equal to $65. So this is my inequality that I'm going to solve. So I can add together the first two things that he bought, and then I can subtract that from 65 to see how much he has left. So it looks like he has $33 left. So I am going to write a sentence explaining this because it's a word problem. I want a word answer. So I'm going to say, Sam may spend up to $33 on the jeans. So I've got my inequality answer right here, and I've got my explanation. So that is what we're looking for word problems. So if you can understand how to solve it, that's one piece, but being able to write it as an inequality is another skill, Okay, our last example, we're going to define a variable, write an inequality, and solve the problem. Define a variable just means to pick your letter for your unknown. So it says twice a number, When you see it say a number, that's where your variable is going to go in because we don't know that number. That's our unknown. So twice a number means 2x. Then it says decreased by 1. Decreased by 1 would mean minus 1. Then we've got our symbol, is at least. So if I have at least $10, that means I've got 10 or more. So I need greater than or equal to. And then 17. Solve this by adding 1 on both sides. 18. Bring down my 2x, divide by 2. And I get x is greater than or equal to 9. So twice a number decreased by 1 is at least 17. So my number is at least 9. My number is at least 9. You should be able to write a summary now. Make sure that you use complete sentences and answer the essential question.